angle properties. So here we're going to look at circles and a few properties relating specifically to angles inside the circles. So let's draw up our circle. So our first one is the angle at the center of a circle is twice the angle at the circumference when standing on the same arc. All right, that's quite a lot to take in, but let's take it slow. So let's draw our center. It says the angle at the center of a circle. So let's draw a couple of lines in. Now, the angle at the center is twice the angle at the circumference when they stand on the same arc. So here's the arc that they're going to stand on. And it's the angle at the center is twice the angle at the circumference. So let's draw in an angle at the circumference. And we're saying the angle at the center is twice the angle of the circumference. So if this one's theta, this one's going to be 2 theta when they stand on that same arc there. So it might help if we can relate it to like a specific example. So let's draw another circle in. And let's put our center in. So if we had 120 degrees at the center here, any angle we make from this same arc, so we're making, this is the arc that we've used to make the 120. If we do any from there to any of the on the circumference, so let's say like we do from there to there and there to there, the angle at the center is twice the angle of the circumference, so that's being 60 degrees. We could have drawn it from here to here and here to here, as long as it was on the same arc, that would also be 60 degrees. And even over there would have been 60 degrees as long as it goes to the circumference. And with this one, we actually get a special result. Let's draw another circle. Let's draw our center. And the angle at the center is twice the angle of the circumference. So this time, let's make our arc from here to here, so we actually get a 180 degree line going through the center. It's 180. And the angle at the center is twice the angle of the circumference. So using this diameter, if we make an angle at the circumference on that same arc, we should actually get a 90 degree angle. So whenever you have a diameter and two chords coming off the diameter, it will make a 90 degree angle. Okay, let's have a look at a couple other angle properties. Okay. Now we've got the angle of the circumference subtended by the same arc are equal. Okay, so what does that mean? So I'm going to draw in this like zigzag type pattern. And it said the angle of the circumference subtended by the same arc are equal. So here we've got our arc and we've got two angles standing on that arc. And those two angles are going to be equal. So if this one's theta, this one's also going to be theta. And these two angles are also on the same arc. So if this one's alpha, this one has to be alpha as well. Let's look at another one. So this next one involves us looking at a cyclic quadrilateral. And a cyclic quadrilateral is just a quadrilateral where all the vertices of that quadrilateral lie on the circle. So let's draw a cyclic quadrilateral in. So we can pick any 4 points on the circle. Let's pick those 4. Join them together to make a cyclic quadrilateral. And our property of a cyclic quadrilateral is that opposite angles in the cyclic quadrilateral are supplementary. So if we call this one A and this one B, and this one C and this one D, A plus B will equal 180 degrees, and C plus D will also equal 180 degrees.